So Fleming's left-hand rule is used to find the direction of the force on a wire which is placed in a magnetic field. So we know the magnetic field always, whenever you're using this rule, you will know the magnetic field which is always from north to south. You will know the direction of a conventional current from the source or the supply. And what you have to do, you will apply a rule, and your thumb automatically represent the direction in which the wire will experience a force. So your index finger should always point towards the south as the first finger. Your second finger represent the direction of the current, and automatically where your thumb is pointing, that will be the force. If thumb is pointing up, the force is top of the page. Thumb is pointing down, force is bottom of the page. Thumb is pointing into, so then force is into the page. If thumb is pointing out of, then force will be out of the page. So these are the four possibilities your thumb may point according to the question. Like in this example, if I want to find, like on the left hand side figure, I want to find the direction of the force. So if I want to find the direction of the force, what is the direction of a current in a magnetic field? So as you can see the arrows, if we close this switch, the conventional current, the current is always from positive to negative. So current will move and it will return to the supply. Now we want to find the direction of the force. If we want to find the direction of the force on this wire in a magnetic field, so we'll use a left-hand rule, Fleming's left-hand rule. So according to, if I apply my rule on the first figure on the left-hand side, my index finger should point towards south. So south pole is up. So my index finger should point towards south. So my index finger should point up. My second finger should represent the direction of the current, because the current is going into the screen. So my index finger should point into the screen. So sorry, the second finger point into the screen. Index finger is pointing towards south. My second finger is pointing the direction of the current. So the current is into the screen or towards the screen, and the so current direction is like this, and a magnetic field is not to south. So direction of a magnetic field in this manner. So I'm finding the direction of the force. So my index finger is pointing towards south, which is up. My second finger is representing the direction of the current, which is into the screen. So where my thumb is pointing, automatically my thumb is pointing out on the right hand side. So what will be the direction of the force when the current is passing through this wire? So the direction of the force is on the right hand side for this wire. Now some examples related to the Fleming's left-hand rule. Now the second figure, like example, if we don't know the direction of the force, it is already shown that the force is upward, but example, if we don't know, like we don't know which direction the wire moves or what is the direction of the force. So we know on the left-hand side is a north pole, and on the right-hand side is a south pole. And the direction of the current, conventional current, as I mentioned in the figure shown. Now we will again apply a rule. And what is the rule? The rule is Fleming's left-hand rule. According to Fleming's left-hand rule, my index finger should point towards south. So my index finger should point on the right-hand side. My second finger, it's not visible to you because it is pointing out of, like second finger is representing a current. So my index finger is pointing towards south. So south is on the right-hand side. The first finger is pointing towards south, which is on the right-hand side. Second finger is representing a direction of the current, which is out of the plane. So where my thumb is pointing, automatically the thumb is pointing up. So this wire will experience the force upward. So this wire experience the force upward, or this wire will move upward. And if you want to find the direction of a force on a wire which is carrying a current, as they mentioned here, the current carrying conductor. So the current is out of the paper. So first finger is pointing towards south. Second is representing, like first finger is pointing towards the south. Second is representing a direction of the current, and automatically thumb will point upward. So force will be, actually this is the same figure for the previous one. Now more exam style question from different past papers. In figure 10.1 shows a wire A and B suspended on two supports so that it is between the poles of a strong magnet. So A and B are the two supports and the wire is placed. The wire is loosely held so that it is free to move. So wire can move any direction depending on the direction of a magnetic field or a direction of a current. Describe and explain any movement of a wire AB when there is a current. A large direct current, a large DC from A to B. If a current is moving in this way, and we want to find the direction of the motion of a wire or direction of the force. So again, which rule we have to use? We have to use Fleming's left-hand rule. So my index finger should point towards south. My first finger or index finger point in the magnetic field or south. So in this example, the south is pointing towards the screen. As you can see, south is in the screen. So my index finger is pointing towards the south. My second finger represents the direction of the current. So current is on from left to right. So that's why my second finger is representing direction of the current. Where my thumb is pointing, my thumb is automatically pointing upward. So what does it mean? It means that this wire will move upward. So what is the direction of the motion of wire? But it's of 3 marks. So how you will gain these marks? So first, the wire carrying the current perpendicular to magnetic field produce the magnetic field which cuts the magnetic field of a permanent magnet or which interact with the magnetic field of a permanent magnet, and it will experience the force upward. So there will be an upward force on this wire when there's a current from A to B. The next part, they are saying there's a large alternating current. Alternating current means the current changes the direction. So example, when the current is from A to B, what will happen to the force? The force will be upward. But when the direction of the current changes, because alternating current changes the direction, so then the current will change from B to A. So when the current changes from B to A, as we will apply the rule, the Fleming's left-hand rule, my index finger should point towards south. My second finger represents the direction. So my index finger is pointing towards south. My second finger is representing the direction of a current. Where my thumb is pointing, like first finger is towards south, second is the current. Where my thumb is pointing, that is the direction of the force. So as the direction of the current reverses, the direction of the force will also reverse. Then it will experience a downward force. So force will be downward. But because it is an alternating current, so when the current is from A to B, it is experiencing a force upward. So when the current is from A to B, it will experience a force upward. But because it is an alternating current, and alternating current changes the direction continuously. So then next moment, what will happen? The current will point from B to A. So as the current will point from B to A, as the direction of the current changes, what will happen? The direction of the force will also change. So when the current is from A to B, the force is upward. When current is from B to A, the force is downward. And this continuously changes because now we have an AC supply. For AC supply, the terminal positive and negative continuously changes. So what will be the effect of this? Like one time the force is up, and one time the force is downward. So as the result, what will happen? This As a result, what will happen? Because the direction of the force is continuously changing, so this causes this wire to vibrate between the magnetic fields or magnetic poles. So as a large alternating current is there, what will happen? The direction of the force continuously changes. Due to change in direction of current, so the wire will vibrate up and down or moves up and down between the poles. So remember, whenever you have an alternating current, an AC current, what will happen? The direction of the direction of the current automatically changes, which cause the change in the direction of the force, and this causes the wire to vibrate. If it is a DC supply, the direction of the force is either up, down, in, out, right, left, like it will be fixed direction. But when it is an AC supply, the direction of the force will continuously change, and that will cause the wire to vibrate. So this wire will not remain So this wire will not remain at its position when the current is from A to B. The wire will move upward. Then the current automatically changes because it's an AC supply, so the wire will move downward. So if we have a wire which is placed in a magnetic field, so example, if this was a wire which is placed in a magnetic field, so when the force is upward, the wire will move up. And when the force is downward, the wire will move down. And it will continuously, because the direction of the force is changing, so the direction in which the wire move will also change, or we can say the wire will vibrate. If it was a DC supply, the wire only experience a force in one direction. Always use the Fleming's left-hand rule to find the direction of the force. Another question, as you can see, the wire A and B hang loosely between north and the south pole. So you can see there is a wire A and B, which is between the north and the south pole. The wire is connected to a supply. There is a power supply. The power supply is switched on and there is a very large DC. Whenever direct current is there, remember the force will be there in one direction. But if it is an alternating current, the force will continuously changes the direction. And they mention here in the question, the wire, there's a current from B to A. So the current is moving from B to A. Now, what will be the direction? Describe what happened to the wire as a power supply is switched on. So to know what will happen to the wire as a power supply is switched on, we have to apply again the rule, the Fleming's left-hand rule. So according to Fleming's left-hand rule, my index finger should point towards south. So because in this case, the south is out of the plane, so my index finger should point towards south, which is out of the plane. My second finger represent, so index finger is pointing towards the south. So this is a bit difficult. My index finger, like example, this is the index finger should point towards south, out of the screen. My second finger represents the direction of the current. So index finger is pointing out of the south, which is like back of me. The second finger represents the direction of the current, which is pointing towards the upward from B to A, where my thumb is pointing. When I apply the rule, index finger is south, second finger is pointing up. Where my thumb is pointing, it is pointing towards the right hand side. So what will happen when we apply the rule? Which direction this will move? So this wire will experience the force towards the right hand side. So it will move towards the right hand side. So the question is, describe what happened to a wire as the power supply is switched on. So when the power supply is switched on, the wire which is carrying a current, this wire which is carrying a current will produce a magnetic field, and it interact with the magnetic field of a permanent magnet. And which direction the wire will move? We can say it will move from left to right, or we can say it will move towards right. So it will bow out or move to right. The wire will experience the force. And it will move towards the right hand side. The second part, the power supply is adjusted, and now there is a large alternating current. Again, the similar question what we have answered. If it is an alternating current, it means the current will change the direction. When the current is from B to A, the force is towards the right hand side. But what will happen if the direction of the current is, because alternating current changes the direction, then what happens, the direction of the current will be, or it will be from A to B, because automatically it changes. So if the direction of the current is from A to B, so my index finger, my first finger is pointing towards the south. So my index finger is pointing towards south, which is, and I will use the left hand. My index finger is pointing towards south. My second finger should represent the direction of the current. So it might not be clear, visible. Like here, my index finger is pointing outward. Second finger is representing a direction of a current, and where the thumb is pointing, so the thumb will point towards the left hand side. So basically it will be opposite to the original. So first, when the current was moving from B to A, the force was on the right hand side, but the direction of the current changes, so the direction of the force will also reverse. So, and because it is an alternating current, so the direction of a current continuously changes. When the current is from A to B, the force is on the left hand side. When the current is from B to A, if the current changes, as it's an alternating current, it is from B to A, so the direction of the force is on the right hand side. So direction of the force continuously changes, and what it caused this wire to vibrate right and left. So remember, AC current passing through a wire always cause a vibration to the wire as the direction of the force continuously changes. If it's in DC current, then the force direction is fixed, so the direction of a motion will also be one way. Another question, figure 9.1 shows a horizontal wire P and Q which is placed in a gap between the north and south pole. There is a current in a wire. The force act on a current carrying wire. On a figure, draw an arrow label with letter M to show the direction of magnetic field. So what will be the direction of magnetic field? The direction of magnetic field is always from north to south. So we will draw an arrow from north to south, and we will label that as M. Then an arrow label F to show the direction of a force due to a wire. So now use a screen annotation. What will be the direction of the force? I already saw a lot of example for you. Just apply the rule. Fleming's left hand rule, your index finger should point towards south on the right hand side, your second finger pointing into, so where your thumb is pointing, yeah, that's right, that force will be downward, because when you apply the rule, when you apply the Fleming's left hand rule, your index finger is pointing towards south and the second finger representing a current. So my index finger is pointing on the south right hand side, my second finger represents the current which is into. So you can clearly see automatically my thumb is pointing downward. So it means the direction of the force for this wire is downward. So we'll label that as F. Then state the effect of reversing a direction of the current. So if I reverse the direction of the current, what will happen to the direction of the force? It will be opposite or it will be upward. Because if it is, when the current is from P to Q, the force is downward. If a current is from Q to P, the force will be upward. Another question, figure 10.2 shows a part of a DC motor. So this is a part of a DC motor. A loop A, B, C, and D is placed in a magnetic poles. The loop is free to rotate about its axis shown, and there is a current in the loop, and the direction of the current is indicated. They already give you the direction of a current is from B to C and B to A and D to C. This is the direction of a current. On a figure, draw arrows to show the direction of the force on side AB and CD. So on side AB, what will be the direction of the force? So what I will use the Fleming's left hand rule. My index finger should point towards the south. So my index finger should point in the direction of a south. If I'm finding the force on AB. So index finger is pointing towards south. My second finger representing the direction. My second finger is representing a direction of the current, which is out of from B to A. So my second finger is pointing from B to A, index finger is pointing south, second finger is representing direction from B to A. Where my thumb is pointing down. So this wire will experience a force downward. And if AB is experiencing a force downward, the direction of the force on AB is downward, what will be the direction of force on D and C? It will be upward. Without applying a rule, I can work out, because if the direction of the current changes, the direction of the force will also change. So this one force down, the other one forces up. You can also work out by using a rule, but if you use a logic that if the direction of the current reverses, the direction of force will also reverse. So index finger is pointing towards south. My second finger is representing a direction of the current, which is into. So my thumb is pointing up, so the direction of the force is upward. Another question, figure 9.1 is a sketch of some apparatus found in a science museum, which once used to show how electrical energy can be converted into kinetic energy. When a switch is closed, the wheels start to turn or rotate. So when we close this switch, the current start to move, the conventional current. This is a metal support, so it will pass through this metal, and then it will go downward, and then out from this. This is a 3D structure, so maybe you find a bit difficult to understand the figure, but this is a 3D figure, 3-dimension. The first part, they're asking why the wheel turned when the switch is closed. So what is the reason for that? The current passing through the wheel so there is a current which is passing through the wheel, produce magnetic field and interact with, or you can also use the term cuts the magnetic field, that is the same thing, or interact with magnetic field of a magnet or a permanent magnet? Which cause the force and will produce a turning effect, we can also say. Turning effect is known as moment, or you can also say torque. That was from block 1. The second part on the figure, draw an arrow to show the direction of rotation. So how this wheel will rotate? First thing, we have to find the direction of the force. So how we can find the direction of the force? Again, we will use the Fleming's left hand rule. According to Fleming's left hand rule, my index finger should point towards the south. So my index finger should point towards the south. In this example, it should point. So it should point towards the south. So my index finger is pointing towards south. My second finger is pointing in the direction of the current. As you can see, the red arrow is representing a direction of the current. So the current is going down. So magnetic field is in, current is down. Where thumb is pointing outward, out of the page. So what will be the direction of the force? In which direction it will experience the force? So it will experience the force outward, like this. So when it experiences the force outward, how this wheel will rotate, or what will be the direction of the rotation of this wheel? As you can see, it is experiencing the force outward. So the direction of the rotation of this wheel will be in this manner. Like if this is a wheel, the wire is there, because it is experiencing a force out, so it will move in this manner. So this was about the force on the current carrying conductor when it is placed in a magnetic field.